Welcome to Lunch and Learn with Industry. Our talk today is why consider utility engineering and what employers look for when hiring engineers by Cameron Doneen from Puget Sound Energy.
Our speaker today is Cameron Doneen. And Cameron was born and raised in the Wenatchee Valley of Washington. He worked as an intern at Chelan PUD while pursuing an undergraduate degree in power engineering from WSU. So he interned at Schweitzer Engineering, which is great, prior to his graduation in 2016. So since beginning his career at Puget Sound Energy, Cameron gained a breadth of experiences through PSC's engineering development program to grow his knowledge of how multiple components of the power system, the complex power system, really work together. He supports PSC's power generation operations and is pursuing a master's degree online through WSU's PSM Power Engineering program. So the way the Lunch and Learn works, since there's many people on the line, is you all start muted. You can ask questions anytime in the chat or comment in the chat. At the end of the presentation, we'll unmute and you can just have open questions. If you have questions, I think that's been some of the funner part. So please feel free to ask questions. We really enjoy hearing them. And like I said, you can type them in the chat window. You can also ask them. And then there's a poll at the bottom of the screen. So we're kind of curious how people hear about the Lunch and Learn and why you came and what your interests are. So if you don't mind taking a quick poll. And then before I hand this over to Cameron, I will do a quick advertisement. So
okay, is this coming through?
Yep.
Awesome. Okay, so to start with, I graduated from WSU in 2016, like Greg said, and I put this PowerPoint together to describe my experience for the first 4 years outside of college. And this presentation, kind of as a preface, is kind of just to help guide me through a conversational presentation. And so it's going to be fairly open-ended, but hopefully it will give a good exposure to what your first couple years outside of college will look like, especially if you do go down the utility engineer route. And I had a little fun with the PowerPoint transitions. They've added so many since I've made one. So about me, as Greg mentioned, I was born and raised in East Wenatchee, Washington. I obtained my bachelor's degree in 2016 from WSU. Go Cougs. I interned at Chelan County PUD, then at Schweitzer Engineering Laboratories while I was an undergrad. I started working for Puget Sound Energy in June of 2016. I took about a month and a half off to go travel. I highly recommend it, especially if you have a job lined up afterwards so that you're not putting yourself in too much of a financial risk due to travel. Currently working towards my master's degree through WSU. It's the online PSM, Professional Science Masters, specific to power engineering, which kind of is a sidestep. I highly recommend it as a power engineer, especially coming from a power utility. It's kind of like a hybrid degree for those like myself that can't decide between, say, an MBA or a master's in engineering. It's about 40% oriented towards business and project management and about 60% oriented towards master's level knowledge of electrical power engineering. So I'll start with why I chose utility engineering and what reinforced that decision in these first 4 years of my career. And we'll go into pros and a few cons for contrast. So there are, in my opinion, a lot of advantages to working as a power engineer, especially in the utility. Compared to other forms of engineering, I would say that this has a relatively high, opportunity to work in the field, which I know personally appealed to me. I have a balance between field work and desk work. I'd say at the moment it's about 50-50, which I think is ideal. Too much of either one can get a little bit tedious. Job security is huge. No matter what the economy is doing, lights need to stay on. It's one of the most recession-proof careers out there, in my opinion. Another big thing I've realized is that the longer you've been around in this industry, the more relevant your knowledge is. And that might sound obvious, but there's many industries out there, especially in tech, that are moving so quick that it seems to me to be pretty difficult to keep up. And, that it's a moving target. People sometimes joke that utilities can be slow moving, but there is absolutely no shortage of things to learn in the utility world. It's the core reason why I'm deciding to go for a master's degree, is just to try to understand it more. But with that being said, there are a lot of major changes happening, especially now with the green energy movement. So you can be on the front end of that technology as well. You can spend your whole career learning about how the single biggest man-made system works, which is the power grid. I've kind of conceptualized it as a mental puzzle, and as time goes on, it's as if you're adding puzzle pieces to that puzzle. You're working towards trying to complete the puzzle to fully understand the interconnecting workings of the power grid, which if you're a power engineer out there, I imagine you know what I'm talking about. There's so many subsystems and so much knowledge that goes into how the system works, and you learn that people take for granted that their lights just manage to come on. It's also a career that it is what you make it, and what I mean by that is that you can really get into like a pretty wild career path where you're driving around the state and on site at a bunch of sites and very hands-on and potentially working as much or as little as you want, and learning as much as you can. Or it can be kind of a very comfortable job if that's what you're looking for as well, where it could be a steady and secure 9-to-5 job that will still be fulfilling, in my opinion. And a big advantage is you can work anywhere in the world, at least anywhere in the world that has electricity. And I personally find it very rewarding and fulfilling, which I think is extremely important for one's career, as it is 5/7 of your waking life up until retirement. So you should look and seek to enjoy that. So for contrast, I threw in a few honest cons, but in my eyes, it's nothing detrimental. Compared to other types of electrical engineering, if you start off at a power utility, a lot of times it's a lower average starting salary, but the world's your oyster, so you can go up or wherever from there. Sometimes, if you want to hint at, it is what you make it, with more field opportunities, though, comes more windshield time. And I'm personally seeing a little bit of that. I think this is definitely the time of my life to do that, but I spend quite a bit of time on the road at the moment, and I will be touching on that later in the presentation. And also in power engineering, there's just a crazy amount of acronyms. Not a major con, I just thought it was funny. So we'll talk about very, very high level engineering the power grid, what general job opportunities there are as a utility engineer, because you may decide, oh, I want to be a utility engineer after college, but you'll soon find out that there's so many subsets of options to choose from at that point. It's almost as if you're basically picking your major again, it seems. So I've conceptualized it as 4 general segments of the power grid from a utilities perspective. Others may segment this off differently than myself, but the 4 segments are the generation side, like the power plants, then substations, and that includes transmission substations and distribution substations, and also switch yards as well. I would say then transmission, and then finally distribution all the way up to the connection point at the customer end. And I will spend the next couple of slides briefly touching on each one. So personally, to start with, I spent the first 2 years working more on the distribution end of the company, and now I've spent the recent 2 years working on the generation end of the company. So jumped from one side of the grid to the other. So for distribution, you can expect a couple different job positions, and I guess I should start with this is from my perspective at Puget Sound Energy, so it may vary. Distribution planning, which is like looking at future growth or maintenance, how to meet the needs of distribution customers in an expanding society, especially over here in the Seattle area. It's always growing pretty quick. And so as far as electrical capacity needs, it's always being assessed. And then I personally worked in the customer and system projects group. I'll go into a little bit more detail on that when I get into my specific experience. But the 3 sub departments in there are called new customer construction, public improvement, and electric first response, also known as regional engineering. Again, I'll define those a little later on here. So the next section is substation engineering. In our company at Puget Sound Energy, we that I can speak to at least, we have a PAC group, which is short for protection, automation, and controls. And they basically do everything with metering to electrical relaying to just control wiring throughout the substation. And then you have the substation assembly group, which is in charge of the bigger pieces of equipment and the layout within the substation fence and kind of building the substation as an overall facility. Oh, and also I've been trying to use photographs that I've personally taken to kind of hopefully help speak to my first 4 years of experience of what I've seen so far. So transmission, unfortunately, I couldn't find any cool transmission line photos, but I did have a photograph of this underground transmission conductor, which I found was pretty impressive. A lot of copper and a lot of insulation. So similar to distribution, there's a department called transmission planning, which again is oriented towards future electrical growth, but on the higher voltage end. Transmission contracts is another department, which basically is, I don't have much experience in that outside of a class I took for the PSM program, but it's coordinating with surrounding companies to basically rent space on each other's transmission lines to allow power flow from one portion of the state or country to the other. And then the load office or EMS, I put this in transmission because I kind of looked at this as the overall view of the power grid for the company. And this department's in charge of, doing remote switching of high voltage breakers and monitoring the entire system for major issues. I know a few people that work in there, and I find it very cool. Unfortunately, I don't have much experience in there. Maybe someday, though. And then finally, generation. I'll speak to this in more detail a little later on as well. So I'm in the department currently called Generation Electrical and Controls, which is a central engineering resource for all the power plants. You could end up being a specific power plant engineer, which would be, you'd be specific to one power plant, and that would be your central working location. We also have a dam safety department, which is specific towards the infrastructure and the scheduling, hydro scheduling and coordination between our hydroelectric facilities. And this photograph here is at our Fredonia combustion turbine generating facility. And this is a simple cycle combustion turbine. I believe it's rated for about 80 megawatts. So my personal track so far. So here's where I'll go in a little bit more detail on customer and system projects. So on the distribution end of things, this was my first 2 years right out of college. And as a little bit of a tangent to that, if you are a power engineering and if you are looking at Puget Sound Energy as a potential employer, this is where entry-level engineers are starting. And I think it's a good philosophy personally, because in this department, I found that I learned a lot of field work experience and project management experience and just soft skills such as customer facing and balancing a lot of small but loud tasks sometimes with anything related to customers. But I found it a very rewarding experience for my career. So I started off in the new customer construction department, which was at the very end of the power grid as far as the utilities perspective is concerned. So this is working with the commercial and residential customers directly for new facilities that are going in. Say it's a new house, say it's a new business. You'd be working with the electricians for the commercial and residential projects, making sure that I put a picture here of a trench inspection, very, very typical site inspection, making sure depth and separation from other utilities looks good. You work with the Patelco, which is the line workers. Here they're setting a pad mount transformer. You also obviously work with Patelco on constructing new overhead infrastructure as well. My next department I worked in for about 8 months was called Electric First Response. This is basically a department designated for when things aren't working the way they should. As you can see by a couple of these photographs, the airplane one was the one picture in the presentation I did not personally take, unfortunately. Oh, and nobody was hurt in that. I should lead with that. Gratefully, nobody was hurt. But I did take the other two. And as a utility engineer for Puget Sound Energy, we're also tasked with responding to storm duty for when things such as this power pole happen due to wind or ice or cars, crashing into power poles, and things get pretty exciting. And I think it's pretty cool. It's very hands-on. Well, not literally, you're not putting your hands on the power lines, but you know what I mean. Again, you'd be working with customers, but this is more to help them fix issues that they're seeing. Maybe their lights are flickering. Maybe they've got a handhole vault like this one here that a tree's warped it. And you work with the serviceman. You're the one that would be dispatching the serviceman to respond to these specific instances. And as an engineer, you would not be the one physically touching any of this. But you'd be working very closely with the represented employees that are the ones manipulating this infrastructure. And I prefer to spend a lot of time with those guys to learn as much about the physical build of this stuff as I can. I find that rewarding, and I find relationships with those people very rewarding as well. Third group in the distribution end of the company I work in was called public improvement. Basically, you'd be working with the cities and jurisdictions. Oh, I see that word got cut off a little bit, but don't mind that. So these are larger scale distribution projects. Basically, if the city comes to you and says, you know, hey, we're putting in a roundabout, we're putting in a culvert, or they just want a general, you know, downtown Main Street improvement where they want all of their utilities undergrounded, you'd be working and coordinating with the city engineers directly in making this effort happen. And and the biggest single project they're working on right now is the light rail, working with Link Transit. That's been going on for several years, and got to see a little bit of that happen while I was in this department for my short time. So my current role now is in generation, electrical, and controls. Another preface is that I do enjoy working for Puget Sound Energy. They do encourage, and I also apologize, I'm on site at one of our power plants and it can be kind of hard to escape some of the sounds, but let me know if that becomes an issue. So they encourage movement around the company in order to see, sorry, trying to get some quiet. They encourage movement around the company, which allows you to see more departments and help you fill out that mental puzzle that is the power grid, which has been extremely helpful for me. So not only is the opportunity there, but it's actually encouraged that you move around the company and get to see as much as possible. So I'm in the generation side now. And to start with, I found this map very helpful for me. It's an overall map of the United States, obviously, and it maps all the power plants in the United States by type and by size. So as you can see at the top, the color coding, and then over here is the size by megawatt. So for example, Grand Coulee Dam in Washington State, you know, that's the single biggest power plant in the United States. And it's interesting to just look around and how, for example, how prevalent hydroelectric is in Washington State and Oregon. And in the Midwest, how much wind is going in, for example. It also helps put in perspective how much the grid is currently relying on thermal power plants at the moment, which at the moment is 100% essential and must be taken into consideration as we move towards more green energy. So I printed this out as kind of a training tool for new engineers in our group, and I thought it would be helpful for this presentation. I drew in Puget Sound Energy's power plants, the ones that the department I work in is responsible for supporting. Here's a zoom in. So Puget Sound Energy has a total of 3.5 gigawatts of power capacity in their fleet. We have about half of that is natural gas, made up of 9 natural gas facilities. We have 4 wind facilities for a total of 775 megawatts, 3 hydro facilities for a total of 300 megawatts. And we're a partial owner currently in a coal facility out in Montana, as you can kind of see the tail end of that, called Coal Strip, but we're in the works of selling off our portion of that ownership, and I believe they're moving towards decommissioning that, but I unfortunately can't speak to that in too much detail at the moment. I need to do my research. So in my department, my cubicle's in Bellevue, and well, now it's at home, but any one of these plants could have a project that's going that would require, one second, guys, sorry. Hey, do you mind if I give a presentation? All right, I'm back. So, and I live in Seattle. My cubicle's in Bellevue. I've been working from home lately. As you can see, that's actually fairly central to where all of our power plants are located in the state. But it does involve a fair amount of windshield time. If I've got something going on out at the wind facilities down in Dayton, at Lower Snake River, Hopkins Ridge, that's like a 4.5 hour drive. But, the company pays for hotels, and you get to meet new people out there and get a completely independent experience at each of these facilities. Every facility is so different, and every facility is a huge learning curve. And I find it extremely rewarding. And to my point before, this career it is what you make it. If you're willing to put in the hours and drive, like, it'll pay off. But it doesn't have to be that much windshield time if you don't want it to be that much windshield time. So some of my experience in the last 2 years so far in this department has been a lot of wiring and controls knowledge. I'm on site here at our Fredonia facility in Burlington, and this cabinet image here on the far right is actually a couple hundred feet from where I'm sitting. We just installed and we're currently commissioning a new control system and excitation system for 2 of our units here. And so it's been invaluable experience being on site, seeing all this happen, being next to the people that are building and testing all this and creating the commissioning plan and troubleshooting when things don't go right. That being put on the spot like that, that's where you learn the most. And, everybody's there to support you, and it's a positive experience. I've been using a lot of NEC code for learning how to do low voltage distribution projects properly. Outage support, as in power plant outage support. So generally speaking, during a power plant outage, there's more opportunity to conduct projects such as this, and those projects can vary very widely. So every outage is very different. Every project is a little different. We do preventative maintenance programs, such as on the flooded batteries or the GSUs, which are generator step-up transformers, or breaker maintenance. We do electrical relay package installs for the generators. I've been learning a little bit about motor control centers and motor circuit protection. It feels a little bit spread thin, but it's over time, it takes time, and it's very fulfilling. It's a good experience so far in trying to understand how the power grid works and just electricity in general. So these 2 other pictures here are our Glacier battery energy storage facility up in Glacier, Washington. It's a 2 megawatt lithium ion battery storage facility. It's kind of like a research and development project. And ironically, I was tasked with putting this backup generator in and propane tank and transfer switch. The purpose for that is during a long outage, when the batteries fully deplete, we want the auxiliary heating and cooling system to keep working, to keep the batteries at nominal temperature. That's the purpose of this backup generator. And this is inside a stator at Snoqualmie Falls Hydroelectric Facility. I learned to do a little bit of generator inspection, learning to understand how to look at a rotor and stator, know what's going on, and then know when something doesn't look right. Got a long ways to go on that as well. So I want to touch on briefly before questions, what do employers look for in general? I was fortunate enough to be on a panel of my colleagues in a hiring recently, and we did several interviews, and I learned a lot being on the other side of the table about candidates that resonated with me and that were memorable and that I leaned towards. And I was surprised about a couple of those things. So I wanted to pass that on to you guys, and hopefully this is helpful. It'll be brief, but hopefully it's helpful. Well, first, irrelevant picture of some batteries. Thought it was cool though. But so some pointers. The things that stood out to me more so than technical knowledge, surprisingly, especially for relatively entry-level positions, such as EIT, Engineer 1, Engineer 2, maybe even Engineer 3, is passion and personality. Like, and I put in good conversation here as well. If you're sitting upright and you're enthusiastic about the potential job in front of you, and you have kind of a good, fulfilling and interesting conversation with the hiring panel or hiring manager, that will stick in their mind so much more than remembering, say, bullet points about what degree you have or what projects you've done. Those definitely help, but a lot of these people are looking for somebody that will get along with their team and will be fun to work with and has a passion to learn and grow. Like, we ended up choosing to hire somebody who has no utility experience. He's an electrical engineer, but he was so interested in a career change towards utility engineering, and the way he talked about it, like, it was very inspiring, even though he couldn't talk to it in too much detail compared to some other candidates. And that really resonated more so than just technical experience. And then relevant experience, that could be internships, but you can really take life experience or other jobs, and there's good knowledge you learn at all those things that are applicable to these types of careers. Like, I grew up in Wenatchee and was worked on my grandpa's wheat farm and learned how to work on combines and big machinery like that. And I found talking about that kind of thing, farmers have good work ethic, and learning how to work on machinery like that went over very well. So think about your life experience, and a lot of it is a lot more relevant than you'd think. So in conclusion, I think utility engineering is awesome. There's a wide array of career options as a power utility engineer. And then again, the departments I've worked in thus far are called customer and system projects. I've got to spend a little time in new customer construction, electric first response, and public improvement. And now generation electrical and controls. In addition, to give a shout out to Greg, Schweitzer Engineering Laboratories, if you're in Pullman and you have the opportunity, that was a fantastic internship. And then my hometown of Wenatchee, Chelan County PUD, was also a fantastic internship. But we're excited. And now I'll open up to questions and kind of open forum discussion.
Hey, that was great. As I was listening to your presentation, it felt to me like you got an entire career in 4 years.
I'm a little tired.
So there's a couple of questions already on the chat. I don't know, Cameron, if you have the chat up, I can read them to you if you don't.
I do.
Okay.
And I think I don't know if this is actually coming through on my screen share or not. So,
the first one was a question about the oil facility.
Oh, the oil facility. So that's actually I don't know if I can go back to that map. How do I do this? Imagine it's in reference to this. one oil diesel facility, 2.5 megawatts, is actually a backup generator for Crystal Mountain Ski Resort that I think back in the 60s, and this has just kind of been word of mouth knowledge. I haven't really worked there too much, but it was some partnership that was worked out between Puget Sound Energy and Crystal Mountain Ski Resort that they were interested in putting a backup generator that would be big enough to run the entire mountain during conditions in which the ski resort didn't have access to, the traditional grid because they're pretty far out of the way. And PSE agreed to maintain and operate it for under a contract of some form. And so that is a little bit of a one-off, but it is basically a big diesel backup generator. What experience is most important to these resource companies now? Well, by resource companies, I'll speak to electric resources. The utility engineering utility career path is in a strange transition right now. So there's quite a few people. A lot of the workforce is on the verge of retirement, and a lot of the workforce is entry level. And I believe it's like a U-shaped curve, her relationship. Like the people in the middle there obviously are there, but it seems that there's less people mid-career in the utility world than on either extremes. And so there's a high demand right now to get people that are passionate to learn and to grow in this realm, and especially from these people that are experienced and are looking to retire in the next couple of years. So, Greg said it feels like I've been all over the place, got a lot of random experience in 4 years. And I think that kind of speaks to that. If you are willing to do that from your end, then they would be happy to teach you as much as you're willing to learn, and to learn from these people that are looking to retire before they retire, because I think there's a concern that there's going to be a lot of knowledge in this industry that might be lost if it's not backfilled by young engineers that want to take it and even run with it and even take it to the next level. So I'd say passion to learn is very important. So I can't speak to that enough. What are some kinds of interview questions that are typically asked? As far as my favorite interview question, and I don't know, I learned it from SEL, so I don't know if this is against the rules, but I ended up using this interview question on our hiring panel, and it's simply describe in as much detail how power gets to your house from source to, say, light bulb. And that question's very interesting to me because the longer you're in this field, the longer you can talk about that. I mean, I know some people that I feel like could talk about that question and answer it for 2 weeks straight nonstop. Whereas somebody who's maybe a freshman in college would run out of things to say in, say, 45 seconds. And so that's a really good gauge of not only how much somebody knows already about the power grid, but also the way they speak about it. Again, it's a lot of the way you answer the questions. And there are the generic interview questions. I think that a lot of Puget Sound Energy's interview questions are more oriented towards like typical admin type questions. And we took that and added some technical stuff to it. But it really is kind of a gauge of just like how willing you are to learn and what your personality is. And, you know, they know you have an electrical engineering degree and you're capable of learning this stuff. And so I would say in an interview, if you don't know the answer to a question, admit it, but run with it and say that you will find the answer and you're willing to learn, and, you know, just show that you really care about it. And because I know that's important to me as well as a lot of my teammates, is that we're looking for somebody who has a passion in this kind of thing, and it's not just an income per se. And so interview questions vary, but if you go into it with that mindset, I think you'll do pretty well. What's the training process for new electrical engineers like? Does Puget Sound Energy have mentorship programs for their new engineers, or do they participate in training programs like NWPPA? A lot of it really is semi-informal mentorship per department. Each department's kind of configured to be able to onboard new employees. So if you're, you know, plopped into a role, into a job position, obviously you haven't ever done before, they expect that, and they're willing to teach you if you're willing to learn. And so you'll probably be working alongside a handful of fellow engineers or project managers or drafters or field personnel as well. And you may have like a primary mentor assigned to you for your typical day-to-day questions, but really it's kind of like a team effort. But in addition to that, well, before COVID, PSE was open to sending engineers to different training programs. Like I've done a couple SEL training seminars since graduation that PSE was nice enough to pay for me to attend. So there are also opportunities like that. But I would say the most of your in the job training is conducted by your teammates, with the expectation you're kind of going into it not really knowing how to do the job. So don't be too nervous about that. Go in, again, passionate, willing to learn, and they'll be glad to have you. Any thoughts on nuclear power and the general aversion to it from the general public? Well, I'm speaking to a panel of engineers, you know, undergraduate as well as some professors. So I only know so much about the topic, but in short, it sounds like, from my perspective, it seems like it's one of those resources at the moment that is, you know, if everything's going fine, it's just putting out steam. It's like relatively green in that sense, and determining what to do with the nuclear waste. It sounds like that's getting more and more refined. However, it is one of those things that if something does go wrong, it can go very, very wrong. And so we are playing with fire with that. So it needs to be, we need to tread lightly. I've heard different theories about decentralizing the nuclear reactor so that it's in, like, say, smaller sub-reactors. So if there's a meltdown, it can be more contained. But now I'm speaking to things that I know relatively very little about outside of watching Chernobyl. So, and we do not have any nuclear power plants at PSE, unfortunately, because I think that would be a really cool experience to learn more how they work. If you do not have the skill to deal with the problems, does the company provide a class for you, or you learn from other workers? That varies. And I would say the answer is both. and in addition to text or online resources. I have very rarely, or I'd even say not at all, been in a position where I felt so stuck and unknowing that I just, kind of felt hopeless. If you're constantly communicating with your team, especially fellow engineers are willing to sit down and work out problems with you. I love doing whiteboard sessions with people. I think that's a ton of fun. And so if you're stuck, I would just say from the get-go, make sure you're having that constant communication with your teammates and you're not isolating yourself. And that can be easy to do right now in this during quarantine. So I would say utilize technology to make sure you're staying in touch with everybody as much as you can. And the more people they say it's not about what you know, it's about who you know. It's both, but who you know really is a very important thing. So make sure you have kind of a network of people that are there that have you back in this kind of stuff.
Hey Cameron.
Yes.
So I think we're running out of time. Those have been really good questions. I see 3 more here. I'm not sure we'll be able to get to them. They're really good questions. Like Stacy asked about how to get your foot in the door at the company, which is probably going to this webinar is probably a good first step too. How about if we wrap it up? And I want to thank you, Cameron, for that really great presentation. I want to thank everybody for the really, really good questions. And by the way, if you want to attend other of these, if you could just do a Google search, WSU Lunch and Learn, you'll find this great webpage that Barb's put together, which has it's got recordings. So if you want to share this recording with any of your friends, or if you want to watch anything again, it'll be up there. And hopefully we'll see you again in 2 weeks. And have a good week. Have a good weekend. Have a good week in class. Go Cougs. Thank you.
To learn more about the Lunch and Learn with Industry webinar series, follow the link in the description, and we'll see you next time on Lunch and Learn with Industry.